Welcome to this video. In this video, we are going to look at the topic linear motion. But for today, we are going to look at the equations of linear motion. In equations of linear motion, the first equation deals with acceleration. From the definition, we know that acceleration is the change in velocity per unit time. So here, acceleration is given by the change in velocity per unit time. So from this one, we can derive the first equation of linear motion, in that we are going to make the final velocity as the subject of this formula. So to make it the subject, we remove the denominator here by multiplying both sides with t. Then we obtain at equals to v minus u, where v is the final velocity and u is the initial velocity, a is the acceleration, and t is the time taken. So we remove u to the other side of the equal sign. We remain with v equals to u plus at, and this one gives us the first equation of linear motion. When we move to the next equation, that is the second equation of linear motion, it will deal with the displacement, in that displacement is given by the average velocity multiplied by the time taken. So here we take that displacement s equals to the average velocity, which is the final velocity plus the initial velocity, divided by 2 multiplied by t. Yeah, so we are going to use this one to find the second equation of linear motion. But now we know the value of v. V is a u plus at. So we are going to take v here and replace it with these ones. So here we say, but v equals to u plus at. So we now replace v here. So s equals to u plus at plus u divided by 2 times t. Time multiplied by t. So from there now, we simplify the equation in this manner. So s equals to u, we open this bracket, plus at plus u divided by 2 multiplied by t. So here we have this constant s. U plus u gives us 2u. So here we have 2u plus at divided by 2 multiplied by t. You now open the whole bracket here by multiplying each constant here with t. So s equals to 2u times t, we get 2ut plus at multiplied by t, we get at squared divided by 2. So each component here will be divided by 2 divided by 2. So 2 will cancel with 2. We remain with s equals to ut plus a half at squared. This one is the second equation of linear motion. We move to the final, and that is the third equation, whereby we are going to use displacement. Displacement s equals to the average velocity, which is v, final velocity plus the initial velocity, divided by 2 multiplied by t. But we know the value of t, but t equals to v minus u over a. So we are going to replace this t with this value, that is the final velocity minus initial velocity divided by the acceleration. So s will be equals to v plus u divided by 2 multiplied by our t here, which is v minus u over a. So to simplify this one, we are going to have s. The denominator remains, that is 2 times a, we get 2a. Then now we start these the components inside this bracket. So v multiplied by v, we get v squared. Then v multiplied by u, we get uv. Then we move to the next one, plus uv. Then u multiplied by v, that is negative u times v, we get minus uv. Then the next one, that is u and u, it will be minus u squared. Then uv and uv cancel. we remain with so our displacement S will be equals to V squared minus U squared divided by 2A. We make V the subject of the formula, so we multiply with the denominator 2A multiplied by 2A. So we will have 2AS equals to V squared minus U squared. Let us make it the subject. We take U squared across the equal sign, so we'll have V squared equals to U squared plus 2AS. This is our third equation. So that brings us to the end of deriving those equations. So in our next video, we are going to look at a few examples on how these equations work. Please like, subscribe, and share this video.